Okay, in today's video, we are going to solve grade 12 exam questions from November 2020 on financial maths. This is paper 1, question 6 from DBE. Okay, this is the question 6 from November 2020 from DBE. The total is 16 marks. Let's get started on the next slide. Okay, let me get the question again. Question 6 from November 2020. This is the question. Okay, question 6. 6.1 on 31st January 2020, Tiepo made the first of his monthly deposits of 1,000 into a savings account. He continues to make monthly deposits of 1,000 at the end of each month up until 31st January 2032. The interest rate was fixed at 7.5% per annum, compounded monthly. 6.1.1. What will the investment be worth immediately after the last deposit? 4 marks. Okay, 6.1 and 6.1.1. Okay, what will the investment be worth immediately after the last deposit? Okay, whenever we are talking about saving or investing, these are the two formulae that should come to your mind. These two formulae should come to your mind whenever we are talking about saving or investing. Okay, in this situation, which of the two we are going to use? If an amount is being deposited at a regular period of time. Okay, if an amount is being deposited at a regular period of time, as in this case, you can see 1,000 is being deposited. You can see it continues to make monthly deposits of 1,000. Okay, 1,000, after that 1,000, after that 1,000. If you have this situation, for you to find the final amount that will be accumulated, you are going to use this formula. You can only use this formula if an amount is deposited once off and left to grow. You are going to use this because of this situation. Continuous. You are going to use this. So this is the formula to use. Now X is equal to 1,000. Okay. X is equal to 1,000 and the interest rate I is equal to, the interest rate was fixed at 7.5% per annum, compounded monthly. Okay, 7.5%, right? 7.5%. You are going to divide by 12 because you are told that this is compounded monthly. Compounded monthly. This is why you have it divided by 12. Okay, 7.5% divided by 12 because it is compounded monthly. Okay, you can also write this like this. I is equal to, you divide this by 100, you are going to have 0.075 over 12. Okay, so this is the interest rate compounded monthly. Okay, and you have N, which is equal to, you can see from 31st January 2020 to 31st January 2032, you have 12 years. Okay, so you have 12 years, you can see. So you are going to have 12 years times 12 because this is compounded monthly. Okay, compounded monthly. For the interest rate, you divide by 12. For N, you have to multiply by 12 because it's compounded monthly. And remember, there is plus 1. Okay, so you are going to have 144 plus 1, which is equal to 145. Okay, 145 payment. Okay, now the question is, where is the 1 coming from? Let me show you where the 1 is coming from. Okay, let me show you where the 1 is coming from. Okay, so I'm going to use a short period of time. let me use from 31st January 2020 to 31st January 2021. Okay, I'm going to use a short period of time so that you can see that, because we can't count all of them. It's too much work. From 2020 to 2032, this is too much work. If you have to count all the deposits, all the payment, we are going to count the number of payment from 31st January 2020 to 31st January 2021. In this case, you can see this is 1 year. You may think that you have 12 deposits in this interval. You may think that you have 12 deposits because from 31st January 2020 to 31st January 2021, you may think that you have 12 deposits, but you don't have 12 deposits. You have 13 deposits. Let me show you that. So let me use a number line so that we can count together. Okay, let me use a number line. So let's start from here. Let's call it 0. So we start with 1st January 2020 and 31st January 2020. Let's say it's day. Okay, let's call it end of January. I'm going to put J. So this is end of January. Okay, 1st of January and then end of January. Okay, so when you read, you can see it continues to make monthly deposit of 1,000 at the end of each month. Okay, at the end of each month. So we are only using a short period of time from 2020 to 2021, not from 2020 to 2032. This will be too much work. I want you to see why am I saying that you have to add 1. Because when you have this, you may think that this is 1 year and you have 12 months, 12 payment, 12 deposit, but that's not the case. You actually have 13 deposit. Let's count, you are going to see that. So the month start from day and the end is day, January. Okay, we continue. Now you start with February and end of February, right? Now you start with March and end of March, right? You start with April and end of April, okay? And then May, end of May, end of June, end of July, okay? You start with August, end of August. You start with September, end of September, right? You start with October, end of October. You start with November, end of November. You start with December, end of December 2020, and you carry on. You start with January 2021, right? You start with January 2021 and you have end of January 2021. Okay, 31st. This is end 31st. You have January day. So if you can count, you can see you start from day. That's your first payment. Not here. This is 1st January 2020, right? 1st January 2020. The payment is done on the 31st January 2020, right? This is your first payment, second payment, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, 12, 13. You can see that. So not 12. So the same way, you are not going to have 144. Okay? So you have 13 payments in this case. So you can apply this here. What you have to do when you have 1 year, as in this case, right? 1 year times 12, because it's compounded monthly, right? 1 times 12, 1 year, 1 times 12, and then plus 1, which is 13 payment or 13 deposit. Okay, you can see that. So N is equal to 145 payment. So now we are going to use this formula, this one. So you have this. Okay, you're going to have this, right? plus I, this is I, you close the bracket, to the power of n is 145, minus 1, you close the square bracket, over I, this is I. So f, the future value, is equal to, let's plug this in the calculator. Okay, this is what I have. I hope you can follow. So you have this. Okay. Now the next question. Okay, now 6.1.2, if he makes no further payments but leaves the money in the account, how much money will be in the account on the 31st January 2033? 2 marks. If he makes no further payment. Okay, no further payment. So how will the money grow? You understand that you are going to use this. No payment are being made at a regular period of time. You are going to use this. So question 6.1.2, you are going to use this formula. No further payment. The money is left to grow. Okay, this is the formula to use. So P will be this one. The money is left. And N is equal to, you can see from this and the money is left to this date. This is 1 year. Okay, in this case, you have 1 year. So N is equal to 1 year. Remember, compounded monthly. So multiply by 12. Okay, so this is equal to 12. Okay, and I is equal to this. Okay, they didn't change the interest rate. The interest rate is still this. Okay, this one. So A is equal to P. This is P. In bracket, you have 1 plus I. This is I. Right? This is I. You close your bracket to the power of N. N is 12. So A is equal to, plug this in your calculator. So you have this 234,888.53. In bracket, you have 1 plus 0.075 over 12 to the power of 12. Okay, this is equal to 253,123.54 cents. Okay, this, right? 54 cents. Okay, so this is what you have after 1 year. Okay, from this date to this date after 1 year. Okay, now 6.2, Jim bought a new car for 250,000 rand. The value of the car depreciates at a rate of 22% per annum annually. Okay, according to the reducing balance method, after how many years will its book value be? This. Okay, 3 marks. So this is what you have to use, but the value is depreciating. you are going to have minus there. Okay, the value is depreciating, you are going to have minus there. Okay, so 6.2, you are going to use this formula, but with minus instead of plus, you have minus because the value is depreciating. Okay, depreciating, you can see from this to this. So this is your initial amount, which is P. Okay, so P is equal to this, and the final amount, which is A, is this one. Okay, the final in the end, right? From this to this. Okay, initial, final. P is initial, A is final. Now you have this. Okay, so this is the final. And you have I is equal to this. Okay, I is equal to 22% per annum. Okay, so you divide by 100, you're going to have 0.22. 0.22. Okay, annually. So you're going to divide this by 1. You're still going to have this. Okay, annually divide by 1, you're still going to have this. Okay, so this is what you have. Now let me close this. The question is, after how many years will its book value be this? You have to find n. Okay, you have to find n, this n. So you have A, you have P, and you have I. Okay, so I is annually, so divided by 1. You're still going to have this. So let's plug everything in there and get n. So A is equal to this, the final amount. P is equal to this, right? P, in bracket you have 1 minus I, this is I, 0.22. You close your bracket to the power of n. So the question is to find n. Okay, you are going to divide by 250,000 on both sides so that you can have this part on its own. So you divide by 250,000, this, right? You have this. This is equal to, you divide by 250,000, you have this. Okay, you have to solve for n. N is the exponent. So for you to solve for n, since n is the exponent, you are going to introduce log on both sides so that you can drop this n. Okay, so you have this on the left side. This is equal to, you take this, you bring it down. Now you have this log of this. Let's carry on. To solve for n, you're going to divide by this log of this, 1 minus 0.22. Log of 1 minus 0.22. You're going to divide by this on both sides so that you can have n on its own. So when you divide this, right, this by log of this, you're going to have n, right, this by this, you're going to have n is equal to, you have this, divide by this. Okay, you are dividing on both sides by this. So you have this, right, this, divide by this. Okay, so this is equal to, plug this in your calculator. Okay, I hope you can follow. Okay, so 4. Okay, 4 years because it was annually. Okay, 4 years. Remember, annually. The question was annually. Okay, so the answer is going to be in years. You can see it was annually. Can you see? 22% per annum annually. Okay, if it was monthly, you're going to have months, but this is annually, right? This is what you have, 4 years. Okay, so now let's move on to question 6.3. Let me do it on the next slide. Okay, now question 6.3. Let me get the question again. 6.3. Okay, 6.3. Mpo is granted a loan under the following conditions. Okay, the interest rate is 11.3% per annum compounded monthly. Okay, the period of the loan is 6 years. The monthly repayment on the loan is 1,500. Okay, 1,500. A first repayment is made 1 month after the loan is granted. Okay, 6.3.1 calculate the value of the loan. 3 marks. Okay, in this case, Paul is given a loan. Okay, we are not given the value of the loan. We have to calculate the value of the loan. 6.3.1, you have this formula. This is the formula that you have to use if you want to know the value of the loan, what the person is given right now. So you have P, which is present value, the loan, okay, is equal to this. Okay, so to calculate the value of the loan, you are going to use this formula. So X will be the repayment. The repayment is 1,500. Okay, so this is X. X is equal to 1,500. Okay, and you have the interest rate is equal to 11.3% per annum. Okay, so you have 11.3% per annum compounded monthly. Compounded monthly. So you are going to divide by 12 because it's compounded monthly. Okay, you can also write this like this. You divide this by 100, which is 0.113 over 12. Okay, and you have N, which is equal to 6 years. Okay, N is equal to 6 years. Remember, compounded monthly. Okay, times 12. So this is equal to 72. Okay, so P is equal to, you plug everything that you have. So P is equal to, plug this in your calculator. You are going to get, let's see, okay, this is what you have. The loan for a period of 6 years. Okay, this is what is granted. Okay, now question 6.3.2. Okay, let me do it here. 6.3.2. Okay, how much interest will Paul pay in total over the first 5 years? Okay, over the first 5 years, how much interest will Paul pay? Okay, over the first 5 years. Okay, she's paying this. Let's calculate how much she's paying for 5 years. Okay, this is what she's paying per month. Okay, so over the first 5 years, Mpo will pay. You have this times 5 years. Okay, this is done monthly. Okay, every month for a period of 5 years. So you have to multiply by 12. Okay, for 5 years, every month. Okay, monthly. This is equal to, you are going to get 90,000. Okay, you can calculate 90,000. Okay, so this is what she's going to pay for a period of 5 years. Okay, now the question is to find the interest, the amount on top for a period of 5 years. Okay, so you are told that the loan that she's given is for a period of 6 years. This is the value, the loan. Okay, you have it. Loan for the 6 years period is this one. So to calculate the interest, we cannot take this, what she paid, minus this. We can't do that because this is for 5 years. You can't subtract the loan for 6 years. Okay, you must have 5 years, what she paid 5 years in 5 years, and the loan for 5 years, not 6 years. Okay, so we have to find the loan for the 5 years period. So you are going to take the loan for the 6 years period minus the loan for the 1 year period. Okay, 6 minus 1, you are going to have 5 years. Okay, this is what you have. Okay, this is for 6 years, right? Minus for 1 year. Okay, for 1 year, you have to calculate it. You are going to use this formula. Okay, for 1 year. So you have x is this. You have 1 minus, in bracket 1, plus the interest rate is this. Okay, this, you close the bracket to the power of minus n. Okay, 1 year. So you have 1 times 12. Remember, compounded monthly. 1 times 12. So you are going to have 1 times 12 minus 12. Okay, 1 times 12, which is 12. You have minus 12. Okay. Okay, let's close the square bracket. Over the interest rate, you have this. Okay, this is equal to, so you have this. Okay, you have this. Can you see this? Okay, so this is the loan for the 5 years period. Okay, now to find the interest, how much interest, right? How much interest will Mpo pay in total over the first 5 years? Okay, now you have 5 years and you have 5 years. Okay, so interest that will be paid by Mpo over the first 5 years. You have this for 5 years minus the loan for 5 years. Okay, so you have 5 years and 5 years. Now you can subtract. This is equal to, what do you get? You have this. Okay, So this is the final answer. Okay, 28,771.52 cents. Okay, we are done with question 6 from November 2020. Until next time, I will talk to you soon.